The next type of bifurcation is known as a transcritical bifurcation. And in this type of bifurcation is basically an exchange of stability between two different fixed points. So two different fixed points approach each other and their relative stability changes as they pass through each other. And the generic example that gives rise to transcritical bifurcation is x dot is equal to rx minus x squared as r changes. And in this equation, the fixed point value x star is equal to r and also 0. Those are the two possible fixed point values. So to understand what's actually happening here, let's again plot x star as a function of x in the three cases of r positive, r 0, and r negative. So again, I'm plotting as a function of x in all cases, x dot. So if r is positive, for example, then we see that the function f this is always an upside down parabola, but at the origin, it starts with positive slope. And so this upside down parabola is going through the origin with a positive slope before it crosses somewhere for positive x. And so we have a stable fixed point for a positive value of x at r, an unstable fixed point at the origin, and the flow is, let's fill in the flow, and the fixed point value here is equal to r. When r is equal to 0, then we no longer have the linear term. We just have an upside down parabola that just kisses the x-axis, and this gives us our marginal point, which is stable on the right-hand side because the flow is to the left, and it's unstable on the left-hand side and non-linearly unstable, so it's slow flow away. And then when r is negative, what's happened is that our upside-down parabola goes to the origin with negative slope, and so we have something that looks like this. This is now the stable fixed point. This is the unstable fixed point, and so we have flow that looks like this for r less than 0. And this unstable fixed point is at minus r. So we can again summarize what we've seen here through a bifurcation diagram. So let's again plot as a function of our control parameter r the fixed point values that exist. We saw that for r positive, the fixed point at the origin was unstable, and so let's draw that in with a dotted line. Whereas for r less than 0, the fixed point at the origin was stable. So let's draw that in with a solid line. So this is the stable fixed point. This is the unstable fixed point. But there is also a second fixed point whose stability is exchanged by this transcritical bifurcation. So for r positive, there was a stable fixed point equal to r, and that became unstable on the other side for r negative. And now we can fill in what is the flow pattern in this bifurcation diagram. For r positive, if we're above the stable fixed point, we're flowing towards it, so the flow is downward. When we're above the unstable fixed point but below the stable fixed point, we have flow towards a stable fixed point. And similarly, we have flow downward below the unstable fixed point. And then we have just the sort of reverse pattern for r negative. We have flow towards a stable fixed point and flow away from the unstable fixed point. So this is the bifurcation diagram associated with the transcritical bifurcation.